So what are we going to learn today? We are going to go over the common tools that you see in the Terra software, as long as the wizard steps, importing projects, loading projects, and then the full field designs such as best fit, multi-fit, smoothing, and offset. The software that can create full field designs is Terra Cutta, Terra Design, and Terra Plane. Now, Terra Design, we will discuss how to create those full field designs during that class. And that class is the 1st of June. But we will discuss today how to create full field landforming designs in Terra Cutta and Terra Plane. Terra Cutta, as you probably already know, but for those who don't, that's the complete landforming package that covers full fields and drains. It runs in a tablet in CAB in conjunction with John Deere's iGrade. You can survey design and implement your landforming design with Terra Cutta. And then Terra Plane is for operators of laser systems who want more accurate laser setup information and on-screen cut fill maps. It allows you to survey a field, break it into regions, create planar designs, and then drive on the map. So we'll discuss today what tools are available for full field designs in Terra Plane. It's important to understand that Terra products are all built using the same basic building blocks. They share many of the same user interface screens and functionalities, and this enables someone to upgrade from, for instance, Terra Plane to a full package of Terra Cutta if they decide to do so. Okay, let's talk about the tools. When you open the Terra on your tablet, this is the first page you see. To load a project, you press the Load Project button in the top left corner or the bottom center. Full screen option allows you to switch between full screen mode or windowed mode. This is helpful if you need to be looking at other pages on the tablet at the same time. Day or night contrast modes are different variations of displaying the screen. Day is classic. The high contrast inverts the colors, and night is black and green. The settings button opens your settings to confirm the correctness of your software configuration. The open manual button will open a digital copy of the manual on your device after the manual's been downloaded. The report button opens up a bug report or feature request window, allowing you to report directly to Terra when connected to the internet. You can find the Terra version you're running in the center of the opening page. Choosing the Wizard button allows you to collect and process elevation data. When starting a new job, this is where you begin. Choosing the Import button will allow importing of third-party data. And finally, choosing the Load Project button. That allows you to open a native terra.tci project file. All right, let's talk about some more of the common tools. In the Collect step, so this tool down here allows you to shift elevation points along a path to fix GPS lag that may occur while collecting data during other applications, such as planning or tilling. These tools let you delete points in a circle along a line. When you enter surveying, you will be in field survey mode, except in Terra Ditch, where drain survey mode is the default. Clicking on the button changes the mode to drain survey mode. You will have drain editing buttons, allowing you to extend, split, or delete the drain line. Of course, we will discuss that in depth in the ditching design session next week. Clicking on the collection mode button again will change you to boundary survey mode. Boundary surveying allows you to survey the outer perimeter of a field. The marker button allows you to set points of interest at selected locations. This is similar to a flag in John Deere software. The GPS info button displays the latitude and longitude of your current position as well as your current heading. When you press it, a window will open with more detailed GPS information. There you will see the serial port parameters, warning thresholds, and all the GPS information currently being received. Pressing the Zoom to Full button will zoom the map in or out to the maximum size that shows the entire surface grid. Choose Show Button Text to switch the buttons from showing icons to showing text. Pressing the Guideline button allows you to add guidance lines on the survey surface. Image overlays allow geo-referenced image data to be imported into a field. You can add an image overlay or load an image from the Op Center. Choose your display options of mode, terrain, or layer. Pressing Add Project will allow you to load another project and swap between them. When surveying or implementing, there are 4 options that control how the vehicle location is tracked on the screen. So there's scroll, direction up, center, and manual. And that's what that button is there that you're seeing being pressed. So let me explain each of those to you a little bit. The scroll option will show the GPS position indicator moving freely on the screen and will move the screen, ensuring that the indicator is always present. When the direction up option is active, the map will rotate to make sure that the direction of the travel is always to the top of the screen. The center option locks the indicator to the center of the screen. As it moves, the map moves to make sure it stays in the center. The map is locked to always have north at the top of the screen. And the last is the manual option. It does not lock the direction of the map or fixate on the location of the indicator. So while surveying or implementing, you can inspect other sections of the map. Those are those options right there with this tool. When starting a project in Terra, you have the options in the wizard to begin collecting new elevation data, import third-party data, or load an existing Terra.tci project. So let's go over each of these options. The wizard is home to the primary functions of Terra software and the place you will find the tools used to survey, design, and implement. Choices from here would include loading your existing .tci projects, the collect step to survey, or the collect step to import a CSV file directly in. Terra software normally reads a .tci project file. External files need to be imported using the import button on that initial screen. These files are then converted into the TCI format. You will first need to select the import type. So up here, you either select ditch tracks, survey data, or surface grids. Ditch tracks are referring to the John Deere Surface Water Pro ditch tracks. Survey data includes elevation data collected in a 2630 or Gen 4 display. The folders can be saved on a flash drive, or you can import them from the John Deere Operations Center while connected to the internet. Survey data also includes data in CSV, KML, and shapefile formats. The surface grids, if you choose that, you would be importing JSON grid files, ESRI, Field Level 2, AGPS, and Trimble grid format. We do have many people using elevation data collected by drones or LiDAR. These files are usually in a CSV format containing an excessive amount of points. It is best to have them filtered and edited down to a more manageable size before you load them to avoid long processing times. So let's go over the steps to import data from your John Deere Operations Center account. Click on Import, then Survey Data, then My John Deere. Remember to have a strong internet connection when performing this task. You're going to be redirected to enter your username and password that is associated with your John Deere Operations Center account. You sign in, and it's going to load your orgs. You pick your org, and then you pick the field. You can also search for fields. If you have a lot of them, search for application or choose an application. It's importing your elevation data and creating a surface. It's best practice to go back to the collect step so that you can look at the elevation data in case you need to clean it up a bit. That's as easy as it gets right there. That's importing directly from the John Deere Operations Center into Cutta or TerraPlane or TerraDitch. Okay, so if you're loading a .tci project, so loading this project can be done by choosing the Load Project button. The Grower Farm Field file structure allows for projects to be easily organized. You can also choose to show all files, and Terra will scan your hard drive for all .tci files. There is a search bar to help locate a particular file name. If you choose a file, then you're able to browse the file location, edit the name, or move it to the recycling bin.
So once a file is loaded, a surface is automatically created in the Terra system. So surfacing is a term used to describe the process of creating a continuous surface map from all of the elevation data points collected in the Collect Wizard step. This is done so that every location in the field has an elevation point associated with it, not just the places where the specific GPS data was physically collected. The software estimates values in all the blank areas between the survey dots or the survey points for every blank position on the map. It looks a certain distance away in every direction to find an actual surveyed point. This distance is called the search radius. Once it finds enough points, it will estimate the blank location based on the fixed data captured. If the automatically generated search radius doesn't achieve what you expected, it's possible to manually adjust the search radius in the bottom left-hand corner of the surfacing page, and then it'll allow you to force the software to search further or less far for points to create a continuous elevation surface. Full field design options in Terra Cutta include best fit, multi-fit, smoothing, and offset. TerraPlane, however, only has the option of best fit, as this system is intended to be utilized with planar implementation tools such as a laser. Best fit creates a plane of best fit for the field or region surface area the software is calculating upon. The best fit calculation produces a single slope and direction required to achieve one single plane, while minimizing the amount of dirt moved within the surface area. The software will try to find the most appropriate line of best fit. However, the primary and secondary slopes can also be manually manipulated and have values forced. Multi-fit builds multiple smaller planes that follow the contours of the natural ground surface to drain water in a single direction, usually in the direction of irrigation or wheel tracks. The minimum and maximum slopes influence the individual plane design, which will improve the drainage on a field whilst moving as little soil as possible by staying true to the existing elevation gradients. A multi-fit design allows the slopes to vary within the set tolerances and can greatly reduce the amount of dirt moved within a field. Dividing a field into regions can further decrease the dirt movement required and allows the user to have greater control on the design process. Here we have some examples of cut fill maps created from a best fit design versus a multi-fit design. This is an exaggerated example, but the principles still apply, where the green areas represent a fill and the magenta represents a cut. The best fit design here requires 332,000 cubic yards of dirt to be moved, while the multi-fit design only requires 29,000. Also, the maximum cut was decreased from 9 feet to 1 foot. The multi-fit design accomplishes this by dividing the field into best fit strips, balancing the dirt within the strips. You are able to change the cut fill color schematic in the settings on T3RRA software. The default colors are magenta for cut areas, green for fill areas, and grey for the no cut or zero range areas. This was developed for colorblind people so they could differentiate between the colors on the map. The other choice is red for cut areas, blue for fill areas, and green for no cut, no fill areas. We added this option a few years back due to the feedback received from our users who were transitioning from other competitive systems. They were accustomed to reading maps with those colors, so you can change the setting whilst designing to decide which colors work best for you. The cut fill ratio box is set to a default of 1. This amount needs to be changed to the correct number based on the type of materials being moved and how much of it will settle or shrink once compacted through the earth moving process. This value depends on soil characteristics and is region dependent. For instance, setting the cut fill ratio at 1.2 means that you are moving at a rate of 1.2 cubic meters of cut to get 1 cubic meter of compacted fill. Enter a max cut for the maximum allowed cut depth. This will produce a warning which will appear to notify you if any designed points on the map exceed this max cut value. Adjustments may be required from the warning. The software will not stop you from creating a design that exceeds these tolerances, but will warn you if you have. Instead, you can return and adjust the design to achieve the desired depth of cut. The import section is used when you need to bring in dirt from a stockpile or export dirt from the field to another area. Change the amount to a negative value when you wish to export dirt. T3RRA allows you to separate fields into regions and create different designs within each region. To create regions, select the Regions button. For example, you can apply different primary and secondary slopes in each region area of a field, or have a best fit plane in one region and a multi-fit surface in another. Press the Split button to confirm the split on selected regions. The Merge button will merge selected regions into one region. The Delete button will delete whatever design exists within the selected region. At this point, the region will not exist as a separate area that can accept designs. The Restore button will restore all deleted regions. To create non-linear split lines, first create multiple splits that intersect, then merge the regions that are not wanted. If you are going to balance the dirt in a project, which contains both a field design and a drain design, then best practice when you are collecting data is to pause when traveling over the drain area. Best practice is to not replicate points by collecting a drain survey driving over a field survey. If a surface and drain exist as one project, the surface must be designed first and the drains designed second. If you decide to go back and alter the surface design, be sure and redesign the drains again as well. Select the Best Fit button to create a plane of best fit for a field. Enter the design details to create a plane, or instruct the Terra software to automatically calculate your design details. Software will try to find the most appropriate line of best fit. However, the primary and secondary slopes can also be manually manipulated. Remember to enter a cut-fill ratio. So here you have the water simulation running on our original surface. I can see the ponding areas. And now we'll run the water simulation on the design surface, and we can see the watersheds. It's created a plane of best fit that's suitable for that surface. And we can see the earthworks details required also. Okay. So let's take a look at the same project using a multi-fit design option. Unlike best fit, you must enter details to generate a multi-fit plane. It won't automatically enter the parameters. If you're unsure what to set for the slope range, there are two options to consider. You can use the I-grade plane calculator to find the average slope percentage. Alternatively, you can find this in Cutta by doing a plane of best fit in a direction and then look at the primary and cross slopes in the plane statistics window. If in doubt, consult an irrigation engineer. If you choose to perform cross-slope optimization, it will attempt to tilt the strip sections to match the actual side slope present. This is used in fields that have high side slopes, such as greater than 2%. It is unlikely to provide any benefit in relatively flat fields. If you choose to perform preliminary side slope adjustment, it causes an initial side slope adjustment to occur. It will attempt to ensure that the side slope is no greater than the minimum row slope. This can be used if water might have a tendency to run across rows rather than down rows. Select the smooth button to create a more regular surface with fewer and more gradual bumps and dips. The smoothing option can be adjusted to produce a stronger or lesser effect as needed. The smoothing strength slide bar controls how smooth by increasing the radius that is used in the calculations. The smaller the slider value, the less of an effect the smoothing will have. Smoothing can be applied to a whole field or individual regions, and it can be applied to the original surface or to an existing design. Directional smooth is a checkbox just below regular smoothing. Directional smoothing causes the smoothing effect to be stronger in a particular direction and weaker in the perpendicular direction. Enter the primary smoothing direction in the provided text box. Smoothing strength in the primary direction allows you to set the influence radius in that direction. Smoothing strength in the primary direction, in the secondary direction, controls the influence radius at the 90-degree angle to the primary direction. Region blending allows you to feather or smooth the edges of regions to allow for smooth transitions between different field sections and design areas. The max allowable slope lets you set the maximum steepness that can be used to achieve a region blend. The distance from region line limits how far into each region the blending effect can take place. In order to help make sure that other design elements are not affected, changes within the region blending may not be obvious in the 2D view, but can be much more prominent in the 3D view or in the cut fill map. So be sure to check the results when using these tools. Select the offset tool to raise or lower the surface height of a field or region. This can help with importing and exporting dirt between different field regions and sections, addition or removal of topsoil, and for pad building. You can manually enter the desired offset amount, which can also be adjusted in the set increments using the up-down arrows. You can also use the calculator to help set the offset amount. The calculator is useful if you want to offset the surface by a certain volume of imported or exported dirt. Negative import values are considered exports. Saving a project allows you to return to it at a later time and ensures that you have a copy of the data in case of accidents. We strongly recommend periodically saving your projects in order to guard against data loss. The Save Project button can be found in the top left corner on any of the main wizard steps. When you press the Save Project button, you will be presented with a screen that will allow you to save to a specific field area. It presents you with a screen that allows you to save using structured files. You can enter a grower farm field project name. You can also choose a previously saved value in any of the fields from the drop-down list, and pressing the final OK will save the project and add the file to Terra's structured file saving system. Clicking on Manually Choose Location allows you to select an alternate location to save on the hard drive of the tablet, and the standard Windows file save dialog will open. The first step in trying to resolve any issues is to refer to our operator's manual on the tablet. We have added a button on your opening page that allows you to download the latest version of our operator's manual whilst connected to the internet. After downloading, you can choose the button for quick and easy access to the manual. It is a searchable PDF, so we suggest typing in a keyword and scrolling through the pages addressing the topic. It gives you step-by-step instructions for using Terra software, and it also contains many tips for troubleshooting. It's a great resource. The second step, if you're still having difficulty, is to give your John Deere dealer a call. This is an example from our operator's manual troubleshooting guide section. The issue was reported as my cut fill map is all one color. The symptoms were that when the implementation or design phase of Terra software, you view a cut fill map and it's a uniform color of no cut and no fill. When you touch part of the map, it shows the cut fill value as being 0. The cause of this is that your original surface and your design surface are exactly the same. This happens if no design has been created and when surfacing first completes. A blank design is created that is a duplicate of the original survey surface exactly. As a cut fill map is the difference between the original surface and the design surface, it will be a map of 0 cut fill values. And the solution is to go to the design step of the wizard and create a new design. This is another good example of what solutions are available in our operator's manual troubleshooting guide section. The issue was reported was the tablet becomes slow and sluggish. The symptoms were that the tablet was slow and sluggish, taking an unusually long amount of time to process. One cause could be that there is an update going on in the background. So if you have the tablet connected to Wi-Fi, the tablet will retain internet access credentials and connect to the internet if it was within range of this Wi-Fi network. Automatic updates from Windows can then start without your knowledge. Two solutions are to either regularly connect your tablet to the internet to provide adequate time for these updates to be installed and complete, or change internet connection options in the tablet settings by turning off Connect automatically whenever a network is within range. We've got many resources available for our Terra product owners. Check out our YouTube, our social media pages, our manuals and quick reference guides. If you don't have access or you'd like help accessing any of our resources that we have available, contact either myself or Gwen.